So I've opened up my source code and I set a breakpoint on the first cout line. And then I ran it with the green arrow, and it came here and it ran and it stopped there. The little yellow arrow means that's the current line. Now I want to skip to the next line. So I'm going to go and find the button that looks like a U-turn around a dot. It says step over. I click that and it runs to the next line. So it actually executed that line. So if I go to the program, I'll see that it said please enter your name. It hasn't executed this line yet. It hasn't let me type in anything yet. So now I'm going to click that step over again. And it's sitting there hanging, waiting for me to type in a name. That's why we don't see a yellow arrow anywhere. Yellow arrow anywhere. We won't see the yellow arrow come back. I don't know why that's hard for me to say. Yellow arrow come back until we actually type in something. So I'm going to type in Joe here. And there. Now the arrow came back. And we're on this line. So this is known as the interactive debugging. And it's actually pretty incredibly important to be able to do this. And back in the old days, punch cards and stuff like that, people could not do interactive debugging. If you hover your cursor over the word name here, you can see what's in it. I typed in Joe, so when I hover my cursor over the word name, it says Joe. If I hover it over the word age, it says 0, because right now that variable has the value of 0. So with an interactive debugger, you can see the values of the variables, and you can see how they change. Down here as well, we see them. There's a variable called name that was created, and it's got the data Joe stored in it. It's kind of cryptic. It says autos. If we click down here next to autos, we see something called locals, and it's got all 4 of our variables declared. Everything that we declared here. I don't know where pounds per year came from. We haven't even used that one yet. Oh, it's down here. Okay. Anyways. Alright, so going on, I'm going to press the step over one more time. That displayed please enter your age to the window. There it is. We haven't typed in anything, so I'm going to click the next step over once more. Now it wants me to type something in. My age, 25. And then now we're at the next statement. The arrow is pointing at this cout, which is wanting us to enter the weight. I'm going to hit step over again. Again. It's going to let me type in my weight. I weigh 250. I've earned 10 pounds per year. All right, now it's at this line. Double pounds per year is equal to, and it's got this funny word here, seal. We'll talk about what that does in just a second. This is a mathematical expression. It calculates weight divided by age, and it rounds it up. That's what seal means, is please round this number up. And it stores it in a variable called pounds per year. Why does it round it up? I'll execute that line now. See, if I hover my cursor over it right now, it's got this weird random value in it. It says, you know, -9 times 10 to the 61. It's just a huge random number. And that's a very important thing to note, is that until a value is copied into a variable with an equal sign, you have no idea what kind of data is in there. It's just randomly assigned. So if I hit step over again, it performs that calculation, and now pounds per year has a good value. And since I typed in 25 and 250, or whatever I typed in, it calculated as 10 pounds per year. So moving my cursor over it, it shows that, you know, it was in fact 10 per year. If I needed to actually change that for the program debugging purposes, I could come down here and I could actually change that from 10 to 11. Just in case you're, you know, if you need to monkey with these values in order to continue debugging, you can change them down here. Now that I've changed it, if I let it execute this next line, which displays the pounds per year, it's going to print 11 rather than 10. How often do you change the values? Well, you know, at first probably not, but you will get used to using the debugger. This is how you solve problems in your program. If you don't know why one of your calculations is going wrong, you open up the debugger. Half the time, if you can't get something to compile, to run correctly, and it's not a syntax error, I'll have you go into the debugger and we'll step through it line by line. Okay, I'm going to do step over. You have gained about. And then if I let it run the next line, it's going to say pause. And that will execute the pause command. Press any key to continue. So that's the debugger. There's a couple of other symbols there too. There's one called step out. If you do step out, it leaves the function you're currently in. We are currently inside the main function, so it would run everything up to and including the end of the main function. And we haven't used functions yet, so that's not going to make a lot of sense. So far, this is the only function in the program. That one right there. CEIL, ceiling, is a roundup function. There's another one called floor, I bet, that would round it down. And so if you pass in to the CEIL function a value that can be rounded down, it will round it down. So just for total grins, go up to the top of your program. Oh, let's stop debugging. Press that little red box there that says stop debugging. Or if you can't find that red box there, choose under the debug menu, stop debugging. So cout 7 divided by 7.0 divided by 3.0, and then followed by the ENDL. And then let's print out the rounded version of that. Cout CEIL, and then inside the parentheses have that same stuff. 7.0 divided by 3.0. And then I'm going to get rid of this breakpoint so that it won't keep stopping. I'm going to come and right click on the breakpoint and choose delete breakpoint. So that when I press the green arrow to run the whole program, it doesn't stop there. Alright, it'll compile and see 7 divided by 3 is 2.3. But if you round it up, it becomes 3. How often are you actually going to use the CEIL function? I'm not really sure. I'm not really totally sure why I threw it in this one, unless I just wanted to make sure that the value displayed didn't have a bunch of numbers after a decimal point. But it does illustrate what a function is. We can create our own functions as well. So up above main, we're going to create a function called, I don't know, what is this one going to be called? It's going to be called divide. It's going to take two numbers and return the division of those two numbers. So I'm going to declare this function as being a floating point type. It needs to return a floating point number, and it takes two numbers. It takes in a number that we're going to store in a variable called a, and a number that's stored in a variable called b. And then it's going to calculate the result of a divided by b. So float result is equal to a divided by b. And then return result. And now I'm going to call that function divide, and I'm going to pass in, I don't know, 10 divided by 5. Excuse me, 10 comma 5. Like that. Save it, do a project build solution, choose build solution, just make sure it compiles without error. And then put your breakpoint on the line that calls divide. Mine is line number 21 because I had this stuff up on it. Yours will be different, but whatever line calls the divide function, go and click on the gray there to put the red dot there, the breakpoint there. And then let's run it. I click the green arrow. It executed that line. It printed out whatever 7 divided by 3 is. It executed that line. It printed out 7 divided by 3, rounded up. And it's stuck waiting on this line. Now if I just click step over, it's going to run everything here and go to the next line. But I don't want it to do that. I want it to actually step into this function so I can watch it do these things as well. That's why there's another symbol up here called step into. It's next to step over. It's one to the left of step over. It's a blue arrow pointing to a dot. If I click step into, it's going to actually go into the divide function as it is called. So I click step into, and boom, now we're up here. We jumped into another function. We went from here to here, and now we are up here, where A is equal to that first number we passed in. We passed in a 10, so A is equal to 10. We passed in a 5, so the B value is set to 5. And we can see that by hovering our cursor over A and B. And then I'm going to click step over so that I can watch it do this calculation. It hasn't done it yet because the arrow is pointing at that line, but if I step over a second time, it performs that calculation. And I can move my cursor over here and I can see what the result is. 10 divided by 5 is 2, so my result variable now has the number 2 in it. And if I click step over again, it's going to return that number. 2 is going to be returned back to here so that it can be printed out. So I need to either click step over one more time or I need to choose step out. I'm inside this function and I want to leave this function. So I can choose step out, which will finish executing that function and return back to here. Now I'm here. It still hasn't printed anything, but it's ready to, because now it knows what this has returned. That returned a 2. So if I click step over now, it's going to print the results of that call. And there it is, it printed 2. So we've defined our own function. What is a function? It's a name that is associated with a block of code. This block of code is only 2 lines long. This block of code is quite a bit longer. The main function has, I don't know, 20 lines of code or something in it. The function is executed, and when we hit a return statement, it leaves the function to go back to where the code was called. So the way the code ran is it ran that line, and in order to finish running this line, it had to call this function. So it ran into the function, copying that value, that argument into the A parameter. It copied that 5, that argument, into the B parameter. And so now A equaled 10, B equaled 5. And so when it calculated the result, it did 10 divided by 5 and stored that in a variable called result, which was 2. 10 divided by 5 is 2. So that variable has a 2 in it. And we return that 2 all the way back up to here so that it could then be printed out. Now, just writing a function that divides one number by another, isn't that fascinating? But, you could write much more complex functions than that. Okay, let's go look at what is going to be our programming assignment over the weekend. Yeah, let's do D. That's a good preface for the BMR application. Hopefully it doesn't have all the source code already built into it like this last one did. But I do think it's very useful to know how to use the debugger. And that was a good reason, good excuse to do so.
So are any of these something we're saving to an in-class?
Yeah, we're going to be doing another in-class assignment. We could either just erase what we've already done, or we could create a new project. And why don't we take a 5-minute break? We've been here a while, so if anybody needs to use the bathroom or get a drink, feel free to do so. See y'all at about 8:38.
You check roll yet?
Pardon me?
You check roll?
I haven't taken roll yet. I will do so when people get back. Thank you for reminding me. Alrighty guys, refresh your Dropbox, because you're going to see 2 different files in the F folder now. should see documents titled BMR. So I'm going to the Dropbox, excuse me, BMI. I'm opening up the one that says BMI assignment.pdf.
My computer wants to restart.
Oh, great. Well, don't let, tell it, no. Yeah. Thank you, Adobe.
Close it, still opened it. I'm good to go.
Okay, yeah, you're good to go. Alrighty, so here's our assignment. Body mass index. We will write a program that calculates a user's body mass index. Now, if you're an athlete or you're heavily into dieting or something, you may have used the BMI. Now, BMI is a calculation for how much you weigh divided by how tall you are, but it's more complicated than that. And you get a number where if you're less than 17, then you're supermodel skinny and you need to check in the hospital. And if you get a number greater than a certain value, then you're considered, overweight possibly. And statistically, on a person-by-person basis, it doesn't mean that much because, you could be a football player, who weighed 300 pounds and you're not fat. You're just really big, but you would have a really high BMI. But statistically, if you calculate, over a population, the average BMI of this state is whatever, the people have an average BMI of 27, then you would have more overweight people in that state than you would in another one where the average BMI was lower. So that's just a long way of saying that we're going to write a program where we calculate the BMI. And here's the formula for BMI. Now, we haven't really talked about all the math symbols yet, but in order to do multiplication, you use asterisk. And in order to do division, you use a slash, which is underneath the question mark. So we are going to need to turn this formula here into something that C++ understands, because we can't just copy and paste that. In fact, that's a picture. So in order to change that into an expression that C++ understands, the first thing we're going to have to know is what are our variables? What do our variables need to be named? We need to pick some variable names. We're going to ask them for their weight in pounds. We're going to ask them for their height in feet. Well, the document here is suggesting that we make their weight variable WT and that we make their height variable called HT. So that'll be good enough. And we'll probably make these floats rather than ints, because people might want to say that, I am 5.5 feet tall to indicate that they're 5.5 feet tall. So this equation is going to be BMI is equal to the weight in pounds, which is WT, divided by, and we need to perform this calculation. It's a height in inches times height in inches. Well, we don't have their height in inches. We have their height in feet. So we'll have to do some kind of calculation before we get up that far. But let's suppose that we've already done that conversion. So that will look like, I should have given myself more room. So BMI is equal to the weight divided by, and then everything in here in parentheses, which is the height in inches, which I'm just going to abbreviate HI, times HI. And then we're going to multiply the whole thing times 703. That is our calculation. And if you're Canadian or French or something and you want to measure yourself in meters and kilograms, it's a different formula to get the same number. So what we're going to do is we're going to ask the user to type in their pounds and their weight, and then the program needs to convert their height in feet to inches. How do you convert from feet to inches? If you're 2 feet tall, how many inches is that?
Multiply by 12.
Yeah, you would multiply by 12. It's 24 inches. So we're going to have a step where we multiply the number of feet by 12 to get the number of inches. And then we're going to run it through this calculation so that we can then print out the BMI. So you can either overwrite that source code document that we just made, or you could do a brand new one. You'll have to get the boilerplate in it, of course. I'm going to be lazy and I'm going to make a new one. File new. I think I need to stop debugging. There we go. So I press the red arrow, the red box to stop debugging, and then I do close solution. File new project. I'm going to put my initials in the file name. I'm going to call it JT_BMI for body mass index. That's the name of the project. It's an empty project. And then under source files, I'm going to right click and do add new item. I could leave the file name source, but I'm also going to call that one JTBMI. You can use your initials, of course. There's no reason for you to put JT in front of yours unless you happen to have the same exact initials. And there we go. Now I need my boilerplate. I save the boilerplate to Visual Studio, so I can just come up to the content section and find it under Unit 1. Unit 1 notes. Why am I not seeing it there? Because I'm not in the right class. Let's do that again. There's my boilerplate. Grab that, paste it into my document, my fresh source code. And there we go. We're ready to rock and roll. All right. So to input the user's weight in pounds and their height in feet, we need to declare two variables. To allow them to type fractional numbers with decimal points, we want to make them floating points rather than integers. So I'm going to do two variables, one called HT for height and WT for weight. Now I'm going to put some comments in my program right here just to help me go along so I don't have to hit the instructions so much. Whoops. Input the person's weight, input the person's height, calculate the height in inches, calculate the BMI, and then display. So that's 5 things I need to do. I'm just going to make comments. You don't have to type these comments, but you could. Ask for weight, ask for height in feet, convert height to inches, calculate BMI, and then display BMI. Those are the 5 things that I want to do. That's kind of my little flow chart. That's my task list. Okay, so I'm going to ask for the weight. I need to prompt them for the weight. Cout, what is your weight in pounds? And I need to read their input in, so I have to follow my cout with a CIN and store that into the weight variable, WT. Asking for the height is the same idea. Use cout. What is your height in feet? Now, why didn't I just ask for height in inches? I don't know. Just to make the program extra hard. I don't know. And then CIN into the other variable we defined called HT. Now I need to convert height to inches. So I'm going to say height is equal to height times 12. That'll multiply it and turn it into inches. I could create another variable to hold that value, but I'm just going to use I'm going to reuse that variable. Alright, now we're going to calculate their BMI. We need a variable to hold the BMI. It's going to be another floating point variable, so I'm going to declare a variable called BMI. I might want to move this variable declaration up here to the HT and the WT. There's no reason to wait until down here to calculate it. I could have tacked on comma BMI up there, but I didn't, so I'm going to do it here. Okay, now the formula, if I correctly recall, was BMI is equal to the weight divided by the height squared, HT times HT, times 703. And then lastly, I want to display their BMI. So C out, your BMI is, followed by that variable we calculated, followed by ENDL. Now comes a moment where I want to compile it and see if it works. So I'm going to choose Build, Rebuild Solution. See how many errors I have. It's rare for me to type something and not have made any mistakes. Did it rebuild it? Oh, there it goes. And it says 1 succeeded, 0 failed. So I didn't have any errors. I can pat myself on the back and wander around and help y'all get any errors out of the way. Here's what the whole program looks like. I had to shrink it down to kind of get it to fit. Sorry about that. If I took out the spaces, then I could make the font a little bit bigger. So I think I'll do that. And if I wanted to, I could put the comments out to the side. Like where I say HT is equal to HT times 12, I could put that on the side instead. And where I say calculate BMI, I could put that out on the side. But I'm going to stop messing with it. I'm going to undo those changes so that it looks like it did before. Alrighty, I'm going to test it and then I'm going to help y'all. I'm going to run it. Let's say I'm a linebacker who weighs 300 pounds and I'm 6.5 feet tall. My BMI is 34. Alrighty, that's reasonable. I'm going to run it again. Let's say I am a model who's 5 3/4 foot tall and I weigh 100 pounds. Yeah, I'm pretty skinny, and as a matter of fact, that doesn't look right. I got those numbers reversed. I said I was 5 pounds and 100 feet tall. That's unlikely, isn't it? Let's run it once more. Alrighty. There we go. And that's realistic too. Okay. So I think that this program is a functional working program.
You said this is an in-class assignment?
That's correct. This is in-class assignment F. We're going to look at the homework, which is rather similar. But, of course, it's going to be more complicated. Not that much more though. So this assignment is called BMR calculator. It calculates a basal metabolic rate, which is the number of calories you burn a day in order to maintain your basic weight. Less than that and your body would start burning, fat and muscle in order to keep you running. Let's open it up, take a look at it. We may edit it as we go on. These instructions I took from another instructor and they're a bit silly, so we may revise them as we go. Okay, so here it is, the BMR assignment, Health and Fitness Software Development. In this assignment, you will write a computer program which asks a person for information about them. The program then computes the number of calories they are burning each day and displays the results. So here's our input. We will ask the user for their weight in their pounds. That's exactly like what we just did. We will ask for their height in feet. We've also done that. Then we will ask for their age in years. And then lastly, we will ask for an activity index, which is a multiplier factor based on how active you are. So we'll ask them for their weight, we'll ask them for their height. Hey, what are you doing? Stop that. Okay. We'll ask them for their height, we'll ask them for their age, and then we'll ask them which of these they fit into. Are they sedentary with little or no exercise? Then they're supposed to type in a 1.2. Are they lightly active? 1.4. Are they moderately active? Exercise 3 to 5 times a week? 1.6. Very active? 1.7. Are they, an Olympic athlete? 2 times a day, running marathons? Then they'll enter 1.9. And then here's a calculation to calculate BMR. And once you've calculated BMR, you multiply it by their activity index and you get the number of calories burned. So here's a person with the following data. They're 135 pounds, they're 5 feet, and they're 61 years old. And their activity index is 1.2 because they're sedentary with little or no exercise. So the BMR value for this person is, under this calculation, 66 plus 6.2 times their weight plus 152 times their height minus 6.8 times their age. And that gives you the BMR, basal metabolic rate. Then you multiply that by the AI, the activity index. So it's that number, the BMR, times the AI, which they entered as 1.2, gives them that many calories. So note, all calculations are approximate. And so here's how we want the program to work. But this is a little bit too wordy. So maybe we'll pare this down a little bit. Nah, this is okay. It'll be a little bit of typing, but you could just copy and paste some of this stuff into your program. You just highlight a line, and you paste it, and you highlight a line, and you paste it. So when you run it, it's going to look like this. The program should display this. To advance your health, we will calculate how many calories you burn per day. We will need data on your weight, height, and age, and what kind of activity you do. All your information will be kept confidential, and no salesman will call. Well, this is really silly. I'm going to delete that line. Then, please enter your weight in pounds, and press the enter key. Then they type in 135. Please enter your height and feet, and press the enter key. And they type in 5.5. Please enter your age and years and press the enter key, 61. Now it's going to ask for the AI, the activity index. So it displays a list of them. These are activity indexes for different lifestyles. Please select yours. If you have a desk job and do no exercise, do 1.2. Otherwise, all the way. If you train hard in sports twice a day, enter 1.9. Based on this information, what is your activity index? And we'll choose OK. I have a desk job and I don't do any exercise, so I type in 1.2. Then it prints out a line of stars just to make things pretty, and it says, here are the results from your computation. You burn 1591 calories per day. Really, this is all just fluff. Let's remove that. Okay. And here's a second run with different information in it. I don't like that line about your information be kept confidential, so there we go.
This document was in our Dropbox.
Yeah, I will upload this into the Dropbox. So you can see it's a pretty similar program, but the calculation is more complex. You have to calculate the BMR first and then the calories. We could make that all one calculation, really. There's no reason to break that up into two calculations. I'm going to take that one and replace it there. Nah, I'm going to leave it the way it is. It's just two steps. The first thing you're going to want to do is calculate that. So like float BMR is equal to blah, blah, blah. And then once you get their BMR, you're going to need another variable for calories. So up at the top of your program, you're going to need the following variables: WT, HT, AG, AI, and then BMR, and then calories. So there we are, Dropbox 3 BMR. It will be due Tuesday night. And what we did today, the BMI program that we just typed in, go ahead and upload that. I see 5 people already have. The rest of y'all go ahead and do so. This is really as far as I wanted to cover. We could lecture a little bit more, but I'm not sure if our brains are kind of topped out or not. Let's see what the next topic to lecture over is. We've seen Boole. We didn't do anything with it. Determining the size of data, we don't care. All right. 5 more minutes of lecture, and then we're going to call it done. So variable assignments and initialization. When you use the equal sign, that's called an assignment. We're assigning the value of 12 to the variable called item. The number 12 gets copied into that variable called item. So the equal sign is called the assignment operator. When you initialize it, that's when you're setting the variable for the first time, often when you're declaring it. So in our programs here that we were editing earlier, we could have been initializing these variables if we had cared. Height is equal to 0. Weight is equal to 0. Sometimes there's no reason to initialize it. You know, in this case, there wasn't any reason to initialize them because we were just going to turn around and copy new variables into them anyways. So they weren't initialized. So we just left them like that. It has to be in the order in which it was specified. The number has to be on the right-hand side, and the variable has to be on the left-hand side. That's because it goes from here into here. You can't copy the value of a variable and store it, in a fixed literal number like that. So this is an error. The only way it would work is if it was vice versa. 12 goes into item. That's totally fine. Item goes into 12. No, that's not fine. So variable initialization is when you initialize a variable that's assigning it a value when it is defined. You can initialize some variables, all of them, none of them, whatever is appropriate for your program. Here's an example. Here's a statement that creates 3 integers. It creates an integer called length, an integer called width, and an integer called area. Length is initialized to 12, width is initialized to 5, and area doesn't get an initialized value. That is where I want to stop. I didn't want to talk about scope yet. So if y'all don't have any objections, getting out a little bit early, why don't we kill class? If y'all need to talk about homework and stuff like that, then we'll continue to stay. I haven't taken roll yet, so let's do that.
Can you show us how to make